Lesson 110, we are solving problems with rational numbers. So basically, we're just putting together all four possible operations, adding, subtracting, multiplying, and dividing, that we've already done separately in previous lessons. So if you look on page 64, example 1, water drains steadily out of a lock to lower a boat from one level to another. What is the boat's change in position each minute? So you can see from the picture here that the boat's being lowered by 3 feet in 4.5 minutes. And the question was, what's the change each minute? So change in position each minute. We're going to need to look at how much did it change divided by how many minutes did it take to change, and we're just going to get a unit rate. Change per minute, feet per minute in this case, is what we're looking at. So you can do a bar diagram here if you want to. We don't necessarily have to do it that way. And then basically is that it's going down 3 feet over 4.5 minutes. So we're going to take -3 divided by 4.5. Remember, 4.5 we have to change to an improper fraction. The book didn't really show this. The -3 we can put as -3 over 1. And then remember, keep change reciprocal. So when you work that out, multiply across, we'll get -6/9. And then we can reduce that to -2/3. Alternatively, since we're multiplying, before you multiply, if you wanted to reduce the 3 and the 9 by a factor of 3, you can. What you have to watch out for if you do the reducing on these problems is that you don't lose your negative signs. Common mistake, people that try and reduce and then lose that negative sign. That was in front of the -3 in this case. So work that out then, -2/3, which means that the boat goes down by 2/3 of a foot every minute. So on the try it, a weather balloon ascended from an elevation of 18 feet below sea level to an elevation of 19.5 feet above sea level. What distance did the weather balloon rise? So we could just kind of draw a picture here if we wanted to. So it's starting out below sea level. Presumably there's no water there just because it's below sea level. So if you want to think of a number line, you can. Below sea level, that'd be like a -18. And then they got up to 19.5. Would be one way to think about. So basically, to get from -18 to 0, they'd have to be going up 18. And then going from 0 to 19.5, they'd have to go up 19.5. So basically, if we just add those two together, that's going to be what we need here. 37.5. Would be 37.5. Good. Okay, so 37.5 feet altogether. The book is maybe making this a little bit more complicated. So they're saying the distance between 2 points is the absolute value of their difference, if you were filling the blanks in here. What I like to do rather than what the book's doing is say, let's take the highest minus the lowest. And then you don't have to worry about absolute values. Okay, high minus low, just like we talked about with temperatures and things before. And then you'll get that. So this would be 37.5 feet. Okay, remember with absolute values, that'd be negative, absolute value -37.5, which would then be 37.5 feet. But again, I like either high minus low, or let's draw a number line and kind of see what's happening there. Example 2, Kevin played a trivia game. Each correct answer is worth 2 1/4 points. And each incorrect answer is worth negative -1/2 point. What was Kevin's score? So you can see here, he had 15 correct and 15 incorrect. So 2 different ways of doing this. One way would be, we know that the correct answers we're going to multiply by 2 1/4, so 15 times 2 1/4. Incorrect are going to be multiplied by -1/2, so 15 times -1/2. And then they changed 2 1/4 to 9/4. They changed the order here for whatever reason, I don't know, but since we're multiplying, it doesn't matter. I would have probably put it as 15 over 1 times 9 over 4, but it's okay. And then same thing over with the other one. The 15 we could put as 15 over 1. We have 2 operations happening, multiplication and addition. Order of operations, we know multiplication is going to come first. So that's how the book went ahead and multiplied over here and over here. Okay. If you're not sure, if you want to play it safe, go ahead and multiply the one on the left first, get your answer. The next step, go ahead and multiply the one on the right. Remember, before we can add fractions together, we need to get common denominators. Again, they didn't show that here, but that's what's going to happen. Oh, actually they did, sorry. Wasn't looking ahead. So common denominator, and then those are working against each other, so we subtract. And since we have a real life problem, we want to change that to a mixed number. So if you divide that, 105 divided by 4, and you should get 26 1/4 points. Okay, so that's one option. Another option is that you wouldn't normally be able to do this, but since he just happened to get the same amount of correct and incorrect problems, basically you could look at what's the difference between what he's going to get for the right ones and what he's going to lose for the wrong ones. So if you take 2 1/4 minus 1/2 is 1 3/4. So basically, if you get one right, get one wrong, you're going to come out ahead 1 3/4 points. Does that make sense? And he happened to do that exact, right, wrong. He happened to do that 15 times. So 15 right, 15 wrong, and work that out, and you'll get the same answer. That really only would work doing it that way if we did the same exact numbers, correct and incorrect. So probably the first way that we did it overall would be probably a better process for us to think about doing. So the try it here is pretty much the same deal. 18 correct answers, we're getting 2 1/4 points for each of those. And 12 incorrect answers, so -1/2 times our 12 incorrect answers. And again, it's the same process of what they just did in the book there, so we're not going to spend much time with this. Anyway, you work that out and you should get 34 1/2 points. So example 3, temperature at 4 p.m. was 2.5 degrees Fahrenheit, and it dropped 0.75 degrees Fahrenheit each hour for the next 4 hours. And the question is, what was the temperature at 8 o'clock p.m. after those 4 hours? So what they did in the book here is they just looked at how much is the temperature changing. So it's going down 75 hundredths of a degree every hour for 4 hours. So that's why they multiplied that by 4. You guys could, if you wanted to, you might be familiar with negative 0.75 being like -3/4. So if you wanted to, you could say -3/4 times 4. Since you're multiplying, if you want to reduce the 4's by 4 down to 1's, and then work that out. and that would give you -3. So overall the temperature is going down by 3 degrees. It was a positive 2.5 degrees. It goes down by 3 degrees, and then we can think about these are working against each other, so we're going to need to subtract them. Okay, different signs take the difference. And then we have more negatives, so it's actually dropped into the negatives here, -0.5 degree Fahrenheit. Pretty cold either which way you look at it. So if we look at the try it, we've got a similar situation here. Temperature at 10 a.m. was -3 degrees Fahrenheit. And then it increased (2.25 degrees Fahrenheit each hour for the next 5 hours. So then we want to find our ending temperature. So first we can look at what our temperature is going to change by overall. So 2.25 times 5. We could change that to 2 1/4 and work it out that way if you want to. And remember at the end here we need to move our decimal over how many places? 2 places, okay? Probably good our temperature didn't go up by 1,125 degrees. So it was at -3, and it's actually going up this time by 11.25. So if we think about with these numbers, different signs, we're going to need to take the difference again. So make sure you line up your decimals. Remember that 3 is like 3.00. And then we can see we have more positives than negatives. So in all, our final temperature here at 3 p.m. would be a balmy 8.25 degrees Fahrenheit. So look at the do you know how number 4. Kara had a savings account balance of $153 on Monday. Tuesday she had 6 withdrawals of $15.72 and a deposit of $235.15. What was her account balance after these transactions? So when we do this, first of all, a little vocabulary. Withdrawal means we're taking money out of the bank. Deposit means we're putting money into the bank. So we'll want to look at both of these ideas. So with withdrawals, were $15.72, and we had 6 of those. So if we multiply $15.72 times 6, mainly if we look at the process here, you guys can do fine with the multiplication part, I'm sure. Okay, and then remember we move our decimal 2 places. So total withdrawals are $94.32. So we could then look at, we had $153. With all our withdrawals, we're taking out $94.32. This would be one way to do this problem. So that'd leave us with $58.68. And then we made a deposit of $235.15. So $293.83 should be our final balance then. Another way you could do this would be to go ahead and add your deposit to what your balance was. In other words, $153 plus the $235.15, and then subtract the $94.32. A third option you have would be to combine your deposits and withdrawals together. So $235.15 minus $94.32. That would be showing us all together how much it changed by, which would actually be a positive number, and then you could add that to the $153. So several different options on how we could work this out and still get the correct answer. So look at number 5. A scuba diver is swimming at the depth shown, which is 46 feet below the surface, and then they swim 0.5 of a foot toward the surface every 3 seconds. What's the location of the scuba diver after 15 seconds? So for this problem, we're looking after 15 seconds, and they are moving every 3 seconds. So if you take 15 divided by 3, you see that we'll have 5 different times that they'll be changing by 1/2 foot. So 1/2 foot, they're changing by that 5 times. So that would be 2.5. So they're actually going up 2.5 feet. They're starting at -46, and they're going up by 2.5 feet. Like we've talked about earlier here, these are different signs, so we're actually going to subtract them. And we have more negatives, which is probably good. We're not floating through the air here. So we would finish up at negative 43.5 feet, 43.5 feet below the surface of the water. We'll look at number 6. Temperature of a cup of coffee changed by negative 54 degrees Fahrenheit over 22.5 minutes. What was the change in temperature each minute? So we went the change each minute. So we'll need to divide this out. We want to find out how many degrees each minute, so degrees per minute means we'll divide our degrees by our minutes. And we know before we do that, we need to change the 22.5 to an improper fraction. So 22 times 2 is 44, plus 1 is 45 over 2. Negative 54 we can put over. And then how do we divide fractions? Keep change reciprocal. Good. Alright, once we get to that point, we've got an improper fraction, so we can divide that out. And then the fraction will actually be able to reduce that. So 18 and 45, we can reduce both of those by 9. And then just make sure you remember this is a negative. So So temperature decreased by 2 2/5 of a degrees Fahrenheit per minute, or if you did decimal, it'd be negative 2.4 degrees Fahrenheit. Generally, just because of we've talked about with repeating decimals and things like that, and just discussions we've had with other math teachers, that we're going to try to stick with fractions rather than changing to decimals if possible. Couple of vocabulary words here that you may see. One is a range. Range is if you take the highest number minus the lowest number, so you're subtracting, okay, high minus low. Another thing is mean, which is sometimes called the average, and that's where we add all the numbers and then divide by how many numbers there are. So again, these are things we've done before, but just a quick refresher on what we need to do in those cases. So this gives you an idea of how to solve problems with rational numbers.